Hello everyone, welcome back to the physics class. In the last lecture we have studied about importance of gravitation, universal law of gravitation. Today what we are going to study is free fall. Now what is free fall? Let's say I have this object in my hand. If I drop it, whenever I consider the air resistance and all other forces are zero, only force acting on this is gravitational force. So when I drop this, if I consider only force is gravitational force, it will go down with some velocity. And this velocity is changing at every point. Okay, if you measure this velocity, you can see it is changing. That means this object is accelerating. Okay, and how it is accelerating? Because of the gravitational force of the earth. Now, by Newton's second law, we know whenever you have force and you apply force to any object, let's say of mass m, it accelerates it. So your force is mass into acceleration. Now here, because this force is provided by Earth, gravitational force, I am giving special name to this A. This acceleration I am writing here is mg. Okay, so g is nothing but acceleration. Now we will try to find out value of this g. Now you know any two objects, they have gravitational force, they have gravitation or force of attraction between them. Any two objects. Okay, so here that means the object that I dropped and Earth, they have gravitational force. Now, you know by universal law of gravitation, this is equal to product of these two objects and distance between that object and Earth. Now here this capital G is universal gravitation constant whose value is same everywhere in the universe. Small m is mass of the object, big M it is mass of the Earth, and these distance between this object and Earth center, or you can approximate that as radius of the Earth. Now this is also gravitational force, this is also gravitational force. So these two equations I can equate. So when I equate this, mg is equal to gm capital M upon d square. This m will get cancelled, so my g is gm upon d square. So acceleration provided by gravitational force is equal to gravitational force into mass of Earth into radius of the Earth. Now, if you know values of all this, you can find value of this acceleration. G value you already know, it is 6.67 into 10 power of minus 11. Mass of the Earth, you can take this as 10 power of 24 kg. And radius of the Earth, 6400 kilometer. Now, you have to convert this kilometer into meter. Now, this you have to do and see what value of G you will get. So, do this calculation, approximately that value that you will get is 9.8 meter per second square. This is unit of acceleration. So, because of gravitational force, acceleration in the object will be equal to 9.8 meter per second square. And now if you see this small g, that is acceleration, it depends on mass and, so I will write as d, radius. That means for different planets you have different value of g. Big G, universal constant, is same everywhere regardless of any planet, but the small g, that is acceleration, it is different for different planets. Why? Because it depends on value of m and d. So depending on mass of the planet and radius of the planet, it will be different for Earth, it will be different for Moon, for Pluto, not Pluto, sorry, it is not a, Pluto is no more a planet, Jupiter, Saturn, Neptune, everywhere depending on mass and radius, the value is going to be different. But this capital G, universal gravitation constant, it is going to be same. So, what we have learned today, gravitational force exerted by Earth gives acceleration to the object which is equal to this small g, whose value is 9.8 meter per second square. And it is not constant, it varies from planet to planet depending on mass and radius of that planet. Thank you.